Alrighty. I'm Matt Hood. I'm a big fan of FHIR. I think it's really cool, and I'm really excited to share with you why I think it's so cool. I'm actually kind of surprised that I've found a few people that have heard of FHIR. I was sort of pretty niche, but has anyone but Adam and Simran heard of FHIR or even used FHIR before? Nice. Have you used FHIR in Ruby or like another language, or have you just heard of it? Cool. Yeah, there's pretty robust implementations for those two. Not quite so much for Ruby as we'll see. But yeah. Anyone else heard of FHIR? No, that's kind of good. So I'm starting from scratch. Well, yeah, I know. There are so many FHIR puns. I've given up trying to make them. Um, yeah, it's a bit much. Cool. I'm going to start this one from a pretty rudimentary perspective, but we're also going to go quite deep on the technicals as well. I want to arrive at something where it feels like you could take FHIR and build a really cool application in healthcare, because that's what FHIR is all about. Hey, there we go. Okay, so there is a problem. It's hard to exchange data between systems in the healthcare industry. It can be hard for lots of reasons. The classic example is there's something wrong with you, so you go to your GP, and then they refer you to a specialist. And so you go to your specialist and reiterate the same thing you explained to your GP and any findings your GP had. Maybe your GP sent them a letter that they've got to read. And then things get worse and you get admitted to hospital, and you've then got to explain what you explained to the GP, to the specialist, try and somehow get the results that the GP and specialist found to the hospital. Maybe you get it together and it's a fax, which still happens a lot because it's often viewed as the most secure method. Maybe it's an email. I've heard anecdotes of emails going to the wrong people, and that being a violation of many laws, but there's no actual good technological solutions to prevent people from making those mistakes. So there's a big problem. I'd even describe it as a bit of a wicked problem, because so many people have tried to solve it and have kind of failed, and I think FHIR has made some of the most positive steps towards solving that problem. I say towards, it hasn't fully solved it. I don't think it'll ever be fully solved, but it's made some really good progress. All right, so FHIR stands for Fast Healthcare Interoperability Resources. I kind of feel like they started with the acronym and then had to find something, because FHIR as an acronym is way more catchy. It's a framework for dealing with data in healthcare applications. I say framework because it's more than a standard. It's more than a technical solution. It's got some really cool technical solutions, and we're going to spend most of this time talking about those. This is a technical meetup, but there's also some really cool social and political ideas in there that are actually helping FHIR to gain some adoption. And I think there's a lot we can learn from that in how we bring technologies into our workplaces, in how we develop open source libraries. There's lots we can learn from FHIR, I think. And so FHIR's goal is to enable interoperability of our healthcare data, to enable the data from your GP to flow nicely to the specialist, to the hospital as needed. All right, so let's look at some of the really, really cool technical ideas that FHIR gives us. So there are some data models, lots of data models. In fact, that's kind of what most of it is. And then it also provides a specification for a RESTful API. So if we have a server that is storing some data, it will be exposing it in the FHIR data models. And we also have a really neat RESTful API for doing really rich queries on all of that data. We won't be talking about the RESTful API so much, because that's something that you can just sort of get into if you find yourself needing to use it. We're going to talk a lot about the data models. We're also going to talk about how FHIR allows itself to be extended, because this is like an international standard framework. There's no way that one central international organization is going to be able to capture all the subtleties of the delivery of healthcare in Australia or in any other country. So it has ways of being extended so it can actually meet the needs in those jurisdictions. All right, we're going to go through a sort of a hierarchy of the things that FHIR defines, and we're going to start with the data types. It almost seems a bit pedantic that FHIR has its own type system, but also it makes good sense, because we're building healthcare applications in a variety of languages across different technologies. It makes sense that we should have a solid type system. We can agree on how we're going to represent a date, a date time, and even more complex things like a human's name or an identifier. There's lots of different things. And we can see how that's done in FHIR with a couple of neat examples. I've started with date time. This is a primitive type. It encodes one value. And to see why they were justified in having their own date format, I'm going to be a little bit gimmicky here. But these are all valid FHIR dates. Year, year month day, a time, we've got time zones. This is all standard ISO 8601. Should have written that on the slide if I wanted to remember it properly. But imagining building a healthcare application, we're in prototype stage. We're not thinking about partial dates. Maybe we are, and if you are, then good on you. But we're probably not. We're probably just sticking with the date time in whatever database or application language that we're building with. FHIR means that we have to take care of that, because when you hit the real world, you'll run into partial dates. You don't want people specifying the 1st of January 2023 to mean just the year 2023, because those two things are different. And having a type system that forces us to pay attention to that and handle it means that when our applications hit the real world, they're actually going to be equipped to deal with that data. So I like that they think of these things for us, and we're going to see a few examples of that. We also have human name, which is a complex data type. So it's composed of primitive types and other complex types. This is another example. It's thought of things that we wouldn't have, thinking about how you might put a person's name in a database. You might have a first name, middle name, last name, 3 columns. But does that capture all of the possible names that you might encounter? Maybe your test data is all sort of Western European typical names, but you're going to have people from different cultures with different name formats. FHIR forces you to take care of all of that from the start. I really like it, and it forces our systems to agree on how those things are going to be represented. And also this screenshot I have here is from the FHIR specification. If you ever implement anything with FHIR, you're going to be looking at this a lot. It explains what attributes we can expect to find in our data model with summaries, the cardinality, the types, and the attribute names. I'm going to have a few screenshots like that. You don't need to really study it too deeply unless you really want to. More that this is the illustration of this is the richness that is available, and this is how sort of well specified it all is, which is really handy when you're trying to build something. All right, the next layer over FHIR and where it gets really interesting is when we get to resources. Resources are kind of like complex data types. They're also a composition of primitive values and complex values, but they model real world things that we care about using in our applications. A resource is the sort of thing we might make a database table for, right? Like we'll have a patient resource, we have vision, prescription, we might have an organization, a practitioner. These are all these real world things that we actually want to model in a consistent way across the industry and across different systems. So I'm going to show some examples to really give you a feel of what they look like. Patient's always a good one to look at because it's kind of easy to empathize with, and what appears there makes sense. And just having a quick scan of these attributes, we can see that this is stuff we would probably think to put on a patient record. We're probably going to store their gender. This is not an exhaustive list. We're going to want to store their contact details. We might want to have an identifying photo, whether what their marital status is. There's lots of patient stuff we might want to encode, and the list goes on if I were to scroll down. And to get a more solid grasp of what this actually looks like, I decided to include the JSON representation of the FHIR patient resource. You can also represent it as XML or Turtle, which I learned about. Has anyone else heard of Turtle? It's niche.
It's great, right?
I want to believe it's great. It looks really cool. Never heard of it until I started looking at FHIR. But if anyone wants to go and look at Turtle.
Learn all about it in the book. Yeah.
Yeah. Oh, is it in that?
It was in that chapter. Just last chapter.
Oh, how did I miss it?
That's so good, yeah.
Yeah, so this is what a patient resource actually looks like. It's just regular old JSON, right? We've got all those attributes we saw on that schematic. They're all here in a way we would expect. But we have a lot of richness over it, right? If we go back and look at this date value, yeah, we've just got a string, but we know exactly what we expect to find in that string. which is more than can be said about your average JSON file. So yeah, I think it's just good to have a look at the real thing. Another cool one is vision prescription, an authorization for the provision of glasses and or contact lenses to a patient. If I were implementing this, I mean, you would have your domain experts, you would be thinking this through, but this gives a great starting point. And for me, looking at it with no knowledge of optometry, apart from my left eye being a little bit dodgy, I can see a richness here. I can see that people have thought about building this data model more than I could. But to me, the coolest resource is the structure definition. FHIR is defined in FHIR, which is kind of awesome. It's a machine readable specification that defines itself. All the resources, complex and primitive data types, even extensions, which I'm going to talk about shortly, are defined as structure definitions. If you want to build FHIR support in your language, that means you can start with sort of like a bootstrapping. You can make maybe a structure definition class and a few other like basic data types, and you can do code generation to build out a FHIR implementation in your language. It's a fun exercise when you're getting into it. So that's really good for getting into the niche FHIR geekery. All right. My third bullet point on the what is FHIR slide mentioned ways of extending, and that's really important. If we go back, for example, to our patient resource, we've got a birth date, which is probably fine in many cases, but we don't have the birth time. For a patient that is a baby, that's probably really important to include in their medical record. We can include it another way. We can add an extension. I'm going to start with an example because I think that's easier. This is another patient resource in our JSON format. It's not going to include the birth time extension. We're going to go for some Australia-specific extensions. So we have this extension attribute on the patient resource. We can see that it's a list. It's got two substructures in it. Each one has a URL. I'm assuming some unique identifier and a value. Different types, but we have URL and value that store some extra piece of data. What this lets us do is essentially add a new attribute to the resource. As we see in the actual definition, it consists of a URL that uniquely identifies what extension this is. So if we want to go looking for our closing the gap registration, we know we can go to the patient resource, we can look in its extension list, and we can scan through to find that extension whose URL is closing the gap. As we can see here, that's our unique identifier defined by HL7 Australia, so we know it's Australia specific, and we know that it's going to have a value that is a Boolean. So any extension can have any kind of value, but the closing the gap extension must be a Boolean. All right, I'm going to just take a break from all that technical explanation and actually just demonstrate some stuff. I'm going to require FHIR client. This is just a FHIR client in Ruby. It's not as advanced as what we see in Java and JavaScript, but it does the job and it's good for a demonstration. I'm going to connect to the public FHIR server provided by Happy. I'm going to set up that client. Then I'm going to do a query on a patient ID that I know ahead of time from scanning around this server. I'm also going to include all the observation resources. So that's just any observation we could take about a patient whose subject is that patient. It's just a join, such as the richness of the FHIR RESTful API. And then I'm going to go through the bundle of resources that are returned, a patient and many observations. I'm going to find that patient resource to be my patient. And then I'm also going to go through and filter out the observations. This is not really important code here. I'm just filtering out some of those results to only get ones that I can display easily for this demonstration. It's not conceptually important. So I'm going to check that everything is looking good with my Wi-Fi, run it, and hope for the best. Okay, it looks like it's connected. So now in my session, I should have my patient and observations list populated. Let's see what comes out of this. So I'm going to extract out the name, the birth date, and I'm going to display a list of observations about that patient. And so it's a bit rudimentary, but we can see I've got the name. Some of the test data on this public server is a bit janky, but we can can understand what's going on here. We're able to get our list of observations. We're getting a description of the observation, the value, and the unit. And so this is useful stuff. We could build an application with this information. So just to go back on how this is implemented, just pulling out the resource code. So that's the observation code, what observation it is, the observation value, and the observation unit. Really simple implementation, but we already get some really, really rich data from it. So this is my making it about Ruby. So that's cool. We can extend, we can fetch, we can query, we can display. But this presentation started off talking about interoperability. And if we think about how we could use these extensions, they're almost the antithesis of interoperability. Like maybe I put in closing the gap registration as the way I encode that, but maybe another system just calls it closing the gap. How do I know how to go looking for their URL? How do I know what type to expect? Maybe they decide to use a string, not a Boolean. By being able to make our own resources on the fly or extend our own resources on the fly, we're harming interoperability. So we need a way to keep this stuff under control and have some governance around it. A profile is what that is. A profile is like an extra specification upon a resource. It says, yeah, we've got this resource, but we're also going to expect certain extensions to appear. We're going to constrain some values with extra validations. We're going to provide some interpretation for some values because there's ambiguity in the base FHIR standard. Profiles actually help us understand what to expect from a resource, and that's where the interoperability actually happens. One system and another, to be interoperable, we must agree on a common profile. Now, profiles can actually inherit. So one profile can be like an extra constraining on another. So we need to agree at some point in the tree, and that's our common denominator that we can be interoperable under. Let's see an example of a profile in the Australian context. AU-Base, collaboration between the Australian Digital Health Agency, is that acronym for those who are unfamiliar? I figure most people are familiar with the CSIRO and the broader Australian FHIR implementers community. It prescribes things like that closing the gap registration. It says, hey, in Australia, if you want to represent closing the gap, this is how you do it. We use this URL, and we have our extension have the value of a Boolean. We have Indigenous status, we have Medicare cards, ABNs, and again, something I learned about when working with FHIR is that Australia Post has its own unique codes for addresses. I didn't know that, but HL7 Australia did, and for that I'm grateful. So AU-Base is how we do FHIR in Australia. It's actually not complete. There's sort of further work to do, but it's the start. And so if you want to represent that in FHIR, that's how you do it. You need to agree with the community under which you're being interoperable, that you're going to use AU-Base. I'm going to come back to that governance aspect in a moment. Actually, I'm going to come back to that governance aspect right now. Now this brings us to the social aspect of FHIR. So we need to build these profiles. We need to gain consensus around these profiles. It's all well and good to just make a profile. If everyone makes their own profile, we're still not interoperable. We actually need to agree. We need to get community buy-in. And this is where I think FHIR is really cool. It's created the technical foundation. It's created a common vocabulary to speak about how we're going to model these healthcare principles. It's removed the petty discussions about how we're going to represent a date format. It's given us a whole great type system that gives us a bedrock we can use, but we still need a way to agree, and that relies on building a community around it. One really cool thing that FHIR does is the Connectathon. Don't know why it's called that. I'd like to know. They're events where people gather to build FHIR. They build FHIR profiles, they build tooling, they build documentation, they flesh FHIR out, and they are relevant to a certain context. We have Connectathons in Australia. I think there's one I think it's Brisbane in August and one in Melbourne in November. And each Connectathon has a particular topic. So I think one of the ones coming up is like pathology and radiology. Like how are we going to facilitate communication between GPs and pathologists and radiologists? Like that's what we're going to focus on. We're going to build those profiles. And the outcome of this will be those authoritative profiles on how we should actually do this, such that after that work has been done, now there is a consensus. It's kind of almost like case law, right? There's this precedent and consensus of how we're going to do this stuff. And now we actually have this social and technical infrastructure to do so. Super cool. And then, this is a bit more common. There is a really good forum for FHIR. It's really active, despite it still being pretty niche. There's lots of activity on that forum. Decisions are made there. The community leaders are there making decisions, organizing the connectathons, gathering feedback. It's very involved. And those community leaders are present and answering beginner questions. I posted a question, and Graham Grieve, the creator of FHIR, who is actually a Melburnian, answered my question in like an hour. I had the creator of the thing. It'd be like if you went to the Rails forum and could reliably expect DHH to answer your questions. Whether or not that's something you want is separate, but it's quite unusual and really helpful when you're using it. So don't feel intimidated because FHIR is huge. The community is fantastic. And then there's also the political aspect. We've got our technical solution. We have a community around it. Now we can get this put into policy. The earliest, most significant example of this was the 21st Century Cures Act in the United States. And one of the many goals of that piece of legislation was to allow patients to have free and immediate access to their medical records. It's kind of crazy that we don't already have that, but that's what it mandated. And to do so, it singled out FHIR as the specification that we're going to use. That all medical record systems need to be able to expose patient data as FHIR. Now, the work to actually create those profiles that will constrain it is still ongoing and will probably always be ongoing, but that infrastructure is there. But now that we have the mandate, that really creates the momentum. And this was pretty early on in FHIR's life. It sort of got going in 2014, and to be mentioned in federal legislation in the United States 2 years later is, I feel, a big part of what helped FHIR get its momentum. We can see other examples. In the UK, the Spine is their sort of central repository for patient data. And you'll see that NHS Digital are sort of getting rid of some of their more legacy APIs, and where there is a FHIR equivalent, they're using it. So in the UK, you can go and query patient data from the Spine using FHIR. They've even got like a public sandbox, so just a few example patients. But when I first did that, I'm like, oh wow, this is actually real. This isn't a virtual thing. Like, if I'm willing to go through the compliance stuff, I can sign up with the Spine and build a healthcare app in the United Kingdom using FHIR and get patient data. Super cool. We're also moving towards a similar thing here in Australia. It's slower. No one's really shocked about that, but it's happening just slowly, and I have faith that it will happen. The Digital Health Agency recently released a big roadmap report. Anyone who's familiar with My Health Record will know that it's a bit anemic. Work is ongoing to expose a FHIR gateway around that, so it can be queried for data, but also have data put on the My Health Record using FHIR. So by doing that, you've expanded the ecosystem around My Health Record, and that is what will actually allow data to reach it. Like, we need that infrastructure to get data onto My Health Record, because currently, as I said, pretty anemic. So these are the technical, social, and political solutions. And the takeaway on those things, I think, is that, a bit janky, come on, Emacs, there we go. We've got our technical, we've got our social, we've got our political. I've already alluded to some parts of this, but to sum it up, we have a technical solution. As part of that technical solution, we allow a community to form around it. In FHIR's case, it's profiles and extensions, but we need some way for a community to contribute and own it and feel like it's theirs, feel like it matters to them, feel like it works in their jurisdiction. And then that community will build the awareness that will lead to it being mandated at a political level, at our federal governments. And by mandating it, that gets those technical solutions actually being used in the real world, which furthers their technical development, which furthers social engagement, which raises more awareness, which increases the mandate to use that technology. I think it's really cool, and I think it's something we can learn from as developers. We think about the technical. mean, it's almost a meme that, you know, technology for technology's sake is useless. But even though we know that, we don't always observe it. And so I think thinking about the technical, social, and political things of our projects all at once is really helpful as we try and get buy-in for technologies in our workplaces. We need to think about the community that's going to form about that technology in our workplace, and we need to think about how that's going to influence in the mandate for that technology in our workplace, or an open source library. We're going to spend a lot of time thinking about our technical implementation, but we need to build a community around that, and there will be politics within the broader context that sees that open source library become mandated in some more abstract sense. So I think FHIR is a really good poster child for starting with something that's technically cool and getting it adopted in a really wide way. So this is my summary. I think I've already gone for a while, so I might come back to this at the end so someone can scan through it. But otherwise, that's all from me. Any questions? Adam.
There are some interesting security and privacy aspects to interoperability of health data. Do you happen to know whether the government or the friend has looked into how to address what information come out of my health record?
Scanning through that document from the Digital Health Agency, I didn't find any references to it, but I wasn't very comprehensive. However, as a part of the broader FHIR ecosystem, there's a thing called Smart on FHIR, which is all about access control. It's authentication with servers and then authorization to access different data. That's at like the resource level, but yeah, it's all about making sure that whoever's accessing has permissions to access it. But of course, you've got to have some authority to grant those permissions. So I guess that's underspecified and it is left to governments.
I was wondering whether you might know any breaking change in the base specification or a stage of breaks that has there been any larger breaking change?
Yes, 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 yes. So FHIR has versions. Recently, R5 was released, but R4 is the most popular one, and then there's still a bit of, I think it's called STU3 kicking around. And so there are breaking changes in those versions. And FHIR has a thing called the FHIR mapping language. They built a domain-specific language to convert between FHIR resources in a variety of ways. And so every time they publish a new version of the FHIR standard, any breaking changes or any changes in resources, where applicable, get a mapping. And so you can take a resource that's authored in R4 and run the mapping to get that equivalent in R5. Obviously, you can't automatically map every piece of data, but it does. It's something they've thought about, and they're aware of breaking changes. But yes, between those FHIR versions, there are definitely breaking changes that will and have bitten me.
So adding to what Adam has asked, in the United States, there is something called HIPAA compliance. How does this deal with that situation where you are not allowed to share the social security number, and if you're using some AWS servers, it has to be secure. Any service basically you use, it has to be that compliant. And I'm pretty sure every other country will have their own security compliances. So is that something we did by including in this version or not?
I don't think so. So the most honest answer I should give right now is I don't know. Everything beyond this is speculation. My understanding is that this is kind of orthogonal to it. The sort of compliance, the security compliance and privacy compliance of your server is sort of separate to the FHIR implementation. So I would think of that as like an implementation specific concern separate to the FHIR standard. Exactly how HIPAA gets involved, I'm not quite sure. That's
my best answer. Question was like, how does this help with your medical records, for example, your blood test reports, all this stuff? Does it include that or just?
Yeah, so basic records is going to be just your demographics, your name and birth date. You already know those. Observations, as I showed in that example, is probably the first place you're going to start looking. So if we Scroll back, lots. Our results still there. So we can see if you had a blood test result, it would appear as an observation, which is quite rich in data. But then there might be more detailed specific results, like we saw the vision prescription. So where things are, where the generic idea of an observation isn't specific enough, then we might hope for a resource which captures that more particularly. But also observations can be profiled as well. So the Australian base, is it Australian base? Maybe I'm thinking of UK core. Anyway, profiles can have sort of lots of different kinds of observations where it's been like, okay, this is how you do a blood test observation. Because the procedures in Australia are going to be different to the UK or any other country. So yeah, that's how you would represent that sort of information in FHIR.
I'd just like to say this is my for a long time. I think you've done an amazing job.
Thank you.
Very complicated well done.
I really appreciate that. Thank you.
That's okay. My background is in motion in space, so
very cool.
Is there anything in Ruby that does that for me at this point, or is it all? Because the issue is I've dealt with a lot of people, and those specs says that data format, you get rubbish. Like honestly, you still have to do the validation through. So having something that does the validation is kind of key to doing that quickly.
They've got all that validation stuff in there. Yep. Wouldn't it just?
Is there a Ruby gem that does this for you?
Almost, but it's abandoned. Crucible, I think it's abandoned. Like the GitHub is like last commit early 2020, I want to say, which to me is abandoned. So it was a Crucible was like a Ruby library around doing validations. The FHIR client that I'm using is a part of that project, so it's kind of stopped with that one. So where I mentioned that Ruby's a bit underserved, I guess there were sort of a few key people pushing Ruby ahead that got bored. Clearly the Ruby implementation doesn't have the institutional support that some of those other languages have. Like Java and .NET are very well served. There are sort of large enterprise players that use it, so you can't go wrong there. But Ruby so far has been more of an open source effort that just hasn't had the backing. This year I've been learning Ruby, and that's sort of been my, whenever I learn something, I'm like, oh, how does this help me implement FHIR? That's kind of been my go-to project, doing the code generation, trying to do the validations. But yeah, Ruby's underserved, unfortunately.
Thank you.
Yeah, very cool. Anyone else? Any other questions?
It's probably kind of continuation of this kind of data visualization. Is there any work to kind of integrate it into observability kind of thing, telemetry, data insights kind of?
I'm not sure. I haven't seen anything. So I've just realized I'm not reiterating any of the questions, and this is probably towards the end, so it might be a bit fruitless. But Anton asked if there are any efforts to bring sort of telemetry and observability into FHIR interactions. And I certainly haven't seen any. It's not in the FHIR standard. I would say that's implementation specific. So I would go looking at your Happy or the .NET equivalents, whatever FHIR implementation you're using, you would have to look to that implementation for observability and telemetry. Oh, I knew it. I was worried that all of the questions were going to be on running a slideshow on Emacs. It's Emacs and org mode, which felt a bit reckless, and I just wanted to be able to run code in the slide as a gimmick. That's the entire reason. I've been sweating on it, and I'm so glad it worked. So yeah, Emacs, org mode, and just some Emacs package called org tree slide. And I guess because this is just an org mode file, I can publish it on GitHub and link to it if anyone's interested in checking it out later. Looks like that's it. All right, thanks for listening, everyone. Really appreciate it.